Hi there guys, and I'm going to see in this video if we can use GROK AI. We're going to put it to the test to see if AI can actually help us get a high availability Kubernetes cluster. So I've been playing around with Kubernetes on my Raspberry Pis. I've got quite a nice little setup now. We've got Rancher running. We're monitoring everything through Grafana. We've got nice dashboards set up here. It's taken me a while to get this far, actually. A couple of weeks of kind of playing around. It's not straightforward, even using a package like K3s, especially when you're doing it on a Raspberry Pi. A lot of nuances that you need to consider when running this stuff on ARM64. So I have a pretty good procedure now, and I've got like a bit of a cheat sheet, and I can pretty much get a Raspberry Pi K3s cluster up and running within 15 to 20 minutes. But now I wanted high availability. So I do actually have that already running. So you'll see I've got two control planes here and two worker nodes. However, this is using the etcd database at the moment. And I would like to use an external SQL database. And I thought, why not give this as a test of AI's capabilities and see how far AI can take us through getting this actually set up. So I do already have a database running on one of my units here. So I've got on my Pi Rancher node, I have installed MySQL, or this was another thing, on the Pi, MySQL didn't work. So I had to install this thing called MariaDB, which basically works the same way. It's got all the same commands, but it's like MySQL, but packaged for ARM64. So I've already actually got this set up, and I've already got a database running on this. And I've tested the connection from my current head node going back there. So that all works. But what I now need to do is convert my existing K3s into a new version, which is going to, instead of using the etcd, is going to use this external database for its storage. It's faster, more reliable way of running things rather than using the etcd. So it's just a more robust way of doing it. So we're going to try and do that using GROK AI. So I've asked it to help me get this high availability cluster set up, and it's given me these steps. So it did actually tell us to go through installing MySQL. So immediately it did actually fail because it wanted me to install MySQL, and it didn't recognize that I needed to use MariaDB. When I actually told it that MySQL wasn't working, then it realized, you need to use this different package. And then it suggested using MariaDB. But it didn't realize that right from the start, even though I specifically had told it this was a Raspberry Pi cluster on ARM64. So a bit of a failure there, but it did correct it once I pointed out its error. Now I've got a choice to make here. I'm either going to try and reconfigure my existing K3s, or I'm just going to kind of format the cards and start from scratch. So I'm going to try and actually just update my existing one so that I don't have to do, hopefully, minimal reconfiguring, but we'll see. I don't want to have to take out the SD cards and flash them and everything again, basically. But I think the same procedure is going to work, and it does seem like I'm going to be overwriting my existing K3s installation. So I'm not really sure. I think maybe I'm just better just kind of going from scratch again. So I might just format the cards. But we'll give this a go anyway, see if the update works. And if it doesn't, then, because they've got this thing here with KubeVip reapplying it. I'm not really sure about this particular section here. But we will give it a go anyway. Okay, so we've already got the database set up. So now we're going to stop and uninstall K3s on our existing head node. So we SSH into our head node, which I've got here. and we're going to run these two commands here, which is sudo systemctl system control stop K3s. That's going to stop the service, and then we're going to uninstall it. Bye bye. That's the end of my K3s setup now. I think I'm going to have some problems because I was running Longhorn and persistence, and my new, you know what, I'm just going to pull out the cards and we're just going to format them, and we'll just start from scratch. So let's do that. Okay, so yeah, I do think that starting from scratch is going to be better. I got bad feelings about trying to update it and migrate the database, so we'll just start from the beginning. So here is my head node number 1 Pi and its SD card. So let's go ahead and flash this using Pi flashing tools. So we'll open this up and we choose our storage. It's going to be this. We'll edit our settings. So this is Pi worker node. No, this is Pi head node 01. Pi head node. Okay. So that's all set up. We do that and we'll press yes, and that's going to flash our card. Easy. There we go. Okay, so while that's doing that, let's take a look at what's going to actually happen. So I'm going to go through this. So this is my kind of steps for setting up the high availability, but this was using etcd. So I think that pretty much now I've got the database already up and running. The only change is going to be that we're going to need to specify that we need to use this external database, which from what I can see from GROK is basically just adding this in to the command when we do the install, just adding in this fact that we have to use this data store, which is running on 10.5.5.3. So this is our Pi Rancher. All it was doing was running Rancher, which isn't too system resource intensive. So I figured I'll run the SQL database on here as well. So 10.5.5.3 and then the port that the SQL database is using. So I think that's all we have to do is just kind of add that into our command for the install. Basically, when I look at kind of the instructions here from GROK, install K3s with the data store. That does just seem to be the only difference. Anything else now? It's taken out. So we've got this data store here, but it's taken out the fact that we're going to set up a cluster, but that might just be because, yeah, you know what, I'm gonna, because I know this particular set of commands worked. So I think all we're going to do is just add in the fact that we need to connect to this data store, and that should be enough. Okay, that's done. So we can put this SD card back in to our head node there, and then we've got head node number 2. We'll flash this in the same way. Actually, you know what? I'm going to put a bigger. I've got a bigger chip here. This one. It's got more storage in it, so we'll go with this one. Okay, so we go to choose storage, wait for that to show up. And all we're going to do on this one is change this to Pi head node 2. And say yes. Excuse me. Okay. I'm going to go and get this one plugged in, and while this one's waiting to flash. Okay, so I've got both of those units now up and running. Should be able to SSH into this one. Say yes, and put in a password. Okay, so head node number 1 is up and running. So over here, basically now on Rancher, on the RaspberryPi, which is 10.5.5.3, we have running on here our database, and this is our head node, or what GROK is referring to as control 1, so control plane number 1. Now, basically, it's skipping some steps here. I know if I do what GROK AI is saying, this is going to fail. When you're installing on the Raspberry Pis, you do have to take a few additional steps. Otherwise, you're going to run into problems when you install K3s. So here we go. Here's what we need to actually do. We need to, and these are from my own notes, this is what I figured out over a period of a couple of weeks when I was experimenting with K3s. So the first thing we need to do on our head node is turn swap off. And then we edit the swap file here, and we'll set this to 0. That's just because basically Kubernetes doesn't like files moving around too much. So the next thing we're going to do is edit this command line here, and we're going to add this line. And once we've done that, we will reboot the unit. Okay, so that's going to kick us out. Now we'll SSH into head node 02. That should already be up and running. Yes, and we do the same thing. So while the other one's rebooting, we'll do it to this. So turn swap off. Set the swap file size to 0. So, you know, as a test of AI, it's kind of failed-ish. You know, it kind of gets most of the steps right, but there's certain nuances, I guess, for Raspberry Pi that it just doesn't quite get yet. So, as I say, I know that if we just did what it asked, we're going to get some failures and permission problems. Okay, this one should be back up now, and it is. So we can log into there. Now we're going to do sudo apt get an upgrade, okay? Now we'll open up another shell here, and we'll SSH into head node 2. Whoops. Okay, and then same thing. We'll run the sudo apt get an upgrade. So that takes a little bit of time to run, as you can see. So while that's running, I'll just explain what we're going to do next. So we're going to install some dependencies, and then we're going to make a couple of directories. Now again, these steps are not here in the GROK AI instructions. But I know that if we just ran this to install K3s, we're going to run into some issues. We're going to have problems with the services starting. We're going to have problems with the folders that it wants to write to. So that's why I know we have to run these steps first. So I have my own little cheat sheet that I've developed. So let's see if that's done. Almost, yes. Okay, and this one's still going. All right, so now we will install the dependencies that we need. So we'll run that on head node 1. Nothing needed upgrading or changing. And then we're going to create these 2 directories. Okay. Now once the other one's finished updating, we'll run the same one here. It's almost done. So we'll run that, and we create these directories. Okay, so our 2 head nodes are now basically ready now to install Kubernetes, and we're going to use this line here. So let me just explain a little bit what's happening here. So basically this is going to install K3s. Data store endpoint. So this is basically the key to all of this. So what GROK is saying that we need to define where Kubernetes should store its data. Okay, And what we're defining here is that we're going to store it at a certain IP address on a certain database. Now, the IP address it's given obviously isn't correct. We're on 10.5.5.7, 3 is our Pi Rancher node, which is where I'm also installing the database. So you see if we do here nmcli, you'll see that this IP address is 10.5.5.3. This is where we have the database installed, and so that's the place where we're going to have to store this. So we're defining here that data store endpoint is in a MySQL database. The login is K3s underscore user, and the password is K3s underscore password. Very secure. Now, under here, then we have the node IP. Okay, that's the IP address of the head node, which we are on now. So head node IP, if we do nmcli, we'll see that our head node IP here is actually 10.5.5.7. Yeah, so that's actually what we should be using. 10.5.5.7. Our advertised address will be the same, 10.5.5.7. And then TLS sans, this is important. This is going to be our VIP. This is our floating IP address, our virtual IP address that will be moved around depending on the availability of whichever head node is the current head node. So basically, we have two head nodes running. If one of them's down, then that virtual IP address is going to shift. Now, all of our worker nodes are going to point to that virtual IP address. So they will always have an available control plane to connect to. That's basically how this works. So we'll take this data store part and we'll put it into here because I've already prepared this. So cluster initialize, and we're going to put this in. Okay. So let's double check all this information here. So endpoint is correct. Our node IP 10.5.5.7. Our advertised IP is correct, .7. Our floating IP is going to be .10. We're going to disable traffic and service LB. That's just because I'm going to use other services like Metal LB for load balancing. And so this is basically all good to go. So we will copy this command and we'll run this on our head node. And with any luck, this is going to install without any problems. And we should have our first control plane already up and running. So it takes a few moments for the K3s service here to start. So I'll just have a coffee while that's happening. And there we go. So kubectl get nodes. There is our Pi head node control plane up and running. Now here's where we're going to do something cool now. So we'll say watch kubectl get nodes O wide. Okay, so now this is a live view of the nodes that we have connected. Okay, it's kind of a live view now. When we install here on our second unit, sorry, here, this is our, that's our wrench node. We'll just get that one out of the way. So when we install here, we should see it pop up here when it joins the cluster. Okay? But there's something that we have to do first, which is we need to get the token. So this token here is what's going to identify us to the K3s cluster and allow us to join. It's like an SSH kind of token, okay? It's going to allow us to join. So you can see that GROK here is saying that we need to put that token in. Now we have to get that token first of all, okay? And where we get that token is from our head node. We're going to run this. It gives us this token. This is what we're going to need. We're going to save that, and I do keep a file where I keep everything kind of arranged. So I need to copy that into here. This is going to be our new token. Okay, and then here we're going to replace this with that also. Okay, so now over here on our head node 1, we'll go back into watch. Head node number 2 is where we're now going to run this next command. So basically it's this here. So again, we're setting the endpoint. Our server, this is one difference here. So the server HTTPS, so we're pointing here to our primary head node, 10.5.5.7. But this particular node's IP is 10.5.5.2. We can just check that with an CLI. And we'll check that here we do have 10.5.5.2. So that's correct. That's the IP address of this node. And then we have our advertise address, 10.5.5.2. The floating address, the VIP, is the same. And everything else is the same. So basically, this is going to run on here. Head node number 2. We execute this. And when this has finished and K3s starts, we should see it join our cluster here if everything has worked. So system starting. There we go. And it's joined and it's ready. There we go. So we now have a high availability K3s cluster on our Raspberry Pi using an external SQL database for its storage. Okay, so now the next part we need to do is add some worker nodes. Now we do already have some worker nodes that are already set up. But there's a few other things that we need to do, I think, before we do that. No, let's add the worker nodes in first. I think that they should just kind of show up. So rejoin the worker nodes. We're going to run this. But with the new key, basically. So we're going to have to replace this key here, the token. And we're going to copy that token into here. Okay. And then the node IP. So that's going to be the IP of the particular worker node. Now I got a record here of what I've called all of this stuff. So Pi worker node here is on 10.5.5.4 and we got .6. So the last one I set up, you see, was .6. So we'll SSH into those and we'll run this. So again, we'll keep this live view open and we should see them join. So we'll go SSH Pi worker node at Pi worker node 01. Pi worker node 01 dot local. And we're in Pi worker node 01 and we'll run this. Whoops. Let's copy the whole thing. So Pi worker node 01 is on IP address .4, I believe, according to my records. Pi worker node 01 is on .4. So all we got to do here is change the node IP to .4, copy that, and we run it here on our worker node. Again, now it's going to go out, download, install K3s. When it starts, we should see it join our cluster. There we go. So worker node number 1 has now joined. Now we'll exit from this. We SSH into worker node number 2. We're going to run the same command, but this is going to be .6. Let me just double check that. .6, yes, for worker node number 2. We'll run this. And then we should see it come up over here. Excellent. Okay, so we have now our high availability cluster running. There's Pi head node 01, 02, worker node 1, worker node 2, all added. Now we've got no actual services running on here at the moment, I believe. If we go kubectl get namespace, we're just going to have our default stuff. Okay, so now we've got to go through and set up Grafana and everything else again. But basically, there we have it. With a little bit of help from GROK AI, it was not too bad. It kind of understood the basic concept, but I don't think you could have relied on it 100% to get it up and running. So now, see, if we go over into Rancher, we're going to see probably now that our cluster is unavailable, obviously because it's gone. So what we'll do now is we need to add our new cluster now back here into Rancher. So we'll just delete this one. There we go. And now we're going to have to import an existing. We're going to go to generic. We'll call it RPi cluster. And we'll go to create. And we're going to use this one here because we're not using any SSL certificates. So we grab this. And we're going to run this on our head node. And then we're also going to run it on our other head node. SSH into head node number 2. Pi head node 02. Yep. Goes into there. Okay. We'll run this also here. Okay, now let's take a look at what's happening. Okay, so it says waiting to be available. Okay, imported but waiting to be available. Now, I ran into this issue last time I set up the high availability, but using etcd. So this is a permissions problem. Now, I didn't run into this when I just install directly. But when I have two head nodes, I'm running into this problem. So I did actually use GROK, I think, to help me solve this problem. Let's see what its answer was. Here, so K3s cluster input issues into Rancher. Okay. So this was basically the troubleshooting that it went through. Okay. So I explained the problem, and it wanted us to verify the connection between Rancher and the control planes. No, it wasn't anything to do with the certificate manager, but it was updating the K3s API basically. So we can the actual solution, I think, was over down here. Inspect the cluster. So the logs from the agent pod provide valuable insights, is what it said. So the agent is attempting to contact Rancher on 10.5.5.3, but it seems to stall. It's to do with the WebSocket permission. So this suggests a potential issue with the WebSocket connection. Okay. So troubleshooting steps, it took us through here. The connection fails, check for network issues, check firewall rules. I'm not running a firewall, so I knew that wasn't the problem. Okay. Inspect the load balancer. If Rancher server is behind a load balancer or reverse proxy, which it isn't. Validate the Rancher certificate. Check the CA checksum. Generate a new import command. So it gave us a bunch of different troubleshooting steps here, which was quite detailed. So here it was checking the endpoint status, making sure that it's done properly, and then at final stage it was re-import the cluster, delete the existing, generate a new YAML, and monitor the progress, check Rancher K3s compatibility. It kind of took us back to the beginning again and started us over again, okay? Now, we checked out the sockets. So why it's failing. So this was to do with ETD CTL failing previously. That was our problem. Now this time we're not using ETC, and so it's imported without an issue. So using the MySQL was actually a little easier, because when I set it up previously using the etcd, it wasn't showing up, and that was to do with a etcd CTL version problem, and I had to update it and change the version. So it's actually gone smoother with the SQL, which is quite nice. So here it is now here in Rancher. We can obviously click on this cluster. We can see what we've got. We've got our 4 nodes, 2 control planes, our 2 workers here. It's been running for 6 minutes, 7 minutes, 9 minutes, and 13 minutes. So there you go. Within 31 minutes, we have deployed a high availability K3s cluster on our Raspberry Pis. Now I still need to set up our dashboards again. So, okay, let's go ahead and set up Grafana. Now I did save this dashboard. I downloaded the JSON file, so I'm hoping that I can just re-import that, and I'm not going to have to reconfigure all of this. That's my hope. So let's see how well that goes. So the steps for installing the Grafana Prometheus stack. Okay, we'll jump over here. So I have some steps that I follow to get this working. We also want to install Metal LB first for load balancing. Okay, so I'm going to go ahead and install first Metal LB. So on our head node, we'll run this. Sorry, the whole thing. There. Okay. Let's check out the deployment. Okay, it's creating the containers right now. If we want to watch the progress, we can just add watch before this. And it will show us the process of the container creating and when it's eventually deployed. Once all this is done, we can move on to the next steps. So we've got one running, so our controller's running. Now it's just going to deploy the speakers. So they're all running. Okay, so next thing we're going to do is create a nano file. Oops, let's exit that. That is called advertisement. This is going to be the IP addresses that Metal LB can assign. So from 10.5.5.100 up to 250. Okay, so we'll save that and then create an advertisements YAML file. And we put this in. So this is basically our Metal LB configuration, and then we will apply both of these. So now we've got load balancing set up and running. Okay. Next thing we're going to do is install Longhorn. Now for that to work, we need to install this dependency, ISCSI, on all of our units. Not only the head nodes, but all of the worker nodes must have ICSCI installed. Otherwise, you will get failures. So let's SSH into Pi worker node, iWorkerNode01.local. And we install ICSCI there. Okay, because we actually updated those worker nodes, it's already installed, so that's quite handy. It's already left over from previously, so we can just go straight ahead and actually install Longhorn. So we'll install Helm first of all. We only need to run this on our head node. Update the Helm repo. Create namespace. And then we'll install Helm. Now, there is something that we've missed out, which is we need to install kubevip. So kubevip is what's going to manage making sure that we have high availability. So I'll just finish Longhorn here. I'll check our storage class, and our default now is Longhorn. Great. Okay, so that's up and running. So we're done with that. We'll install Prometheus and Grafana in a moment. So there is another step actually that we need to do, which is installing kubevip. Okay. So kubevip is going to take care of our high availability. If you remember, when we were setting everything up a moment ago, we had our virtual IP, this virtual IP address, 10.5.5.10, that we were using. So we actually need to set up kubevip, because this will take care of managing that entry point. At the moment, we technically don't have high availability. We've got 2 worker nodes, but there's no actual high availability there. So we need to make some changes actually here. Yes. So set up our primary control planes, which we've done. Okay, and then, yeah, we need to install kubevip. So our nodes here, you see, we input this 10.5.5.10, okay, as our server address. So all of our worker nodes are looking to this address here, 10.5.5.10, to find their control plane. But we don't have that actually operational at the moment. We haven't got that management of that floating IP up and running yet. So what kubevip is going to do is it's going to monitor our head nodes, and if one is not available, it's going to switch that 10.5.5.10 IP address over to whichever one is available. So that's basically what this is going to do. So we need to install that. So we create this on our head node there, and then we're going to copy this. It's quite a long manifest, but this is going to be what takes care of everything. Now the important part to change here, I believe, is the IP address here. So our VIP address, 10.5.5.10. So that's the IP address that we want to use. So exit this. Now we'll apply that. Okay, so that now has deployed kubevip. Now we can check it's running. There. Okay, so kubevip is now up and running. So we should now have that floating IP address pointing nicely to everything. So yeah. So then add worker nodes. And there's a final thing, which is to add taints. If we want to prevent our control planes from being utilized for deployments. So you got a choice here. We can use our control planes to also run containers, maximizing the amount of power that our cluster's got, or we can taint those so that nothing will be scheduled on them. Those control planes are only going to be working as control planes. So I'm actually going to do that to prevent our head nodes from having anything running on them. So we'll taint those two. Okay. So now over here in Rancher, we'll see that they've now been tainted and nothing will be scheduled on these. So only our worker nodes will do work, and our control planes are dedicating all of their resources only to controlling the cluster. They will not be doing anything else. Now, here in Rancher, we can go into there and we can see what's actually running on these, and we can alter the configuration. So you can add taints and things also here through Rancher, actually. So you can see the taints that we've got here, yeah, that are actually operational. So Rancher is kind of useful for seeing exactly what's going on within our cluster here. Okay. So we've added those taints, and now I think we should all be good. So if we go kubectl get nodes wide, we can see here all of our nodes that are running, control master planes and our worker nodes, and everything is running okay. So we're all good. Now, we've got kubevip up and running. So there is a way now that we could test persistence. So confirm HA setup with embedded etcd. No, that's not what we're doing. We want to actually test the persistence. So we'll go back over. That's the one. Okay. That was troubleshooting. The MariaDB. I think it was the step-by-step guide here. Okay, that's what we wanted. So this is our GROK guide. So now we can test high availability. Okay. So simulate node failures. So power off control plane 1, verify the cluster access via the VIP, and then restore the node. So let's see. I'm not sure exactly what that means. I mean, we should still see everything up and running, I guess. We should have all of our services still running. And then restore the node and ensure it rejoins the cluster. Okay, so basically, yeah, that's what we're going to do. All right, so head node number 1, we'll go sudo shutdown. Okay, so that's going to shut down in a minute or so, scheduled for shutdown. Now when that shuts down, let's see. Watch kubectl get nodes wide. Okay, so once that shuts down, which should do in another 40 seconds or so, we should see that head node disappear, but everything else still be kind of functional. And then when head node comes back, it should rejoin. Let's SSH into here. And we'll ping 10.5.5.10, which is our virtual IP, our VIP. Now, once the head node shuts down, once it gets detected here as not being available anymore, okay, so it's shut down now, we should see the ready status change. And when that happens, the VIP should switch over to head node 2. with no timeouts, I guess. So if we ping 10.5.5 or just ping pi head node 01 dot local, no response as expected because it's offline, it's shut down. It's funny, it's still showing as a ready status in here. Let's see what it shows here. You got 4 nodes. At the moment, yeah, so it's off because they're unavailable. So now it's recognized it as being unavailable, not ready. Okay. Now when we power this back on, it should just rejoin the cluster and just carry on working. So I'll just go and power that on. Should be able to power it on. Switch. It's head node number 1. So yeah, so currently red. Okay, green, so that's powered back on. We've powered on that Pi. So once that boots up, it should rejoin seamlessly to our cluster. So it will take it maybe a minute or so just to boot up and rejoin. And that will confirm our high availability. Then we'll go on to installing Grafana. And there it is. It's come back up. It's ready. It's rejoined the cluster. Okay, so that's great. That's all working. Excellent. Okay, so now let's install Grafana and get that working and see if we can import our old dashboard. So let me go over to my little cheat sheet here. We've already got Longhorn done. Okay, so we're going to download the Helm chart here. SSH back into our head node. Okay. And then we'll create this values file. So we go nano values.yaml. This here is going to define our Grafana setup with persistence using Longhorn and everything else. So this basically is going to make sure that everything's working. And we've got persistent storage. We're setting it up as a load balancer type. We're using port 80 and so on. There's our, you can set the password here for Grafana, and we set our endpoint 10.5.5.7, which is our head node. Okay. But you could also change this to 10.5.5.10 now, which is our control plane, because I got a suspicion that if we point to .7, we're not going to have the high availability if that goes down. So I'm going to change this to .10 because that actually is our VIP for the control plane. So for high availability, I think it should be .10. Load balancer type, everything else good. Okay. We'll close this and we'll run this and install. Happy helming. Okay, so we install using the Helm chart with YAML. Okay, we've got a problem there. I think we should create the namespace first. Yeah, kubectl create namespace monitoring. Now we'll run it again. Okay. Yeah, I've seen this problem before. I just have to run this first. And then we run this. There we go. Okay. So that will download and install Prometheus and Grafana stack. And once that's done, we should see that running, and we should see it exposed using MetalLB that we installed earlier for load balancing. So we'll just wait for that to run. Now for load balancing, MetalLB will assign it an IP address, and then over here in Pi-hole, it's going to make us log in again. I thought it might. So we log in here in Pi-hole, and we go to our local DNS records. All we're going to have to do is update our local DNS records with whatever the new IP address that MetalLB assigns. So grafana.home is going to become something else. That's up and running. Okay, excellent. So we'll go kubectl kubectl get service in namespace monitoring, and we can see the IP address that's been given. So it's been given .102, which is the same, which is great. So no need to change that. Alert manager is 101, and Prometheus home is 100. So there's been no changes from last time. So that's great. So these should all actually work. But what isn't going to be there is my previous desktops, because it's new installation, I think. So we'll log in here, admin, prom operator. There we go. Yep, dashboard not found because it's gone. Okay, so what we're going to do is set this up again. So we'll go to new folder. We'll call this K3s Pi cluster. Create that. Now we're going to import via a JSON. So I downloaded the JSON file earlier. We'll select all of this. Should be a select all here. Is there not? No. Okay, no problem. We'll just grab it all like that. It's quite long. And we'll copy this JSON into, and I don't know why Grafana doesn't have an upload JSON option, why you have to copy and paste it in. I'm not really sure. There should be just an upload option. There we go. So we'll grab all of that, paste it into here, load. It says it's not a valid JSON. Oh, because we didn't go all the way. Yeah. Just select all. Weird. Text, select all. There we are. So there must be it somewhere. Okay. Go over here in Grafana. I'm going to select all this again. Get rid of it. Copy that in. Go to load. Pi cluster. Import. There we go. Everything's back. So there we have it. I think this video is long enough, but that's a high availability K3s cluster running on our Raspberry Pis with an external MySQL database. So hope you found this useful. Thanks for tuning in, and I'll see you next time. Oh, don't forget to like and subscribe if you got this far. Bye.